We all check the weather forecast before heading out, but what about the weather report from space? Beyond the blue skies and fluffy clouds lies a realm of powerful, invisible forces originating from our sun. This isn't just about pretty auroras, it's about space weather, and some of its most dangerous aspects remain largely unknown to the public. Imagine a force that could disrupt power grids, disable satellites, and even pose a threat to air travel, all without a single drop of rain or gust of wind. In this video, we'll explore the hidden dangers of space weather, the events that cause it, and why understanding it is becoming more critical than ever in our increasingly technology-dependent world. Get ready to discover the most dangerous space weather you never knew about. When you think of space weather, solar flares might come to mind, those intense bursts of radiation from the sun. While flares are indeed powerful, a more insidious and potentially catastrophic threat often accompanies them: coronal mass ejections, or CMEs. Imagine the sun burping out a colossal cloud of magnetized plasma, billions of tons of solar material hurtling through space at millions of miles per hour. If Earth is in the path of one of these CMEs, the consequences can be severe. Unlike the immediate radio blackouts caused by solar flare X-rays, CMEs take a day or more to reach us, giving us some warning. But when they hit, they can trigger powerful geomagnetic storms. These storms aren't just pretty light shows like the aurora. They can induce powerful electrical currents in our power grids, potentially causing widespread blackouts. These blackouts could last for days, weeks, or even months. Think about the impact: no electricity, no communication, no internet. The Carrington event of 1859, the most powerful geomagnetic storm on record, caused telegraph systems worldwide to fail, even electrocuting operators and setting telegraph paper on fire. A similar event today would be devastating to our modern interconnected society. What makes CMEs particularly dangerous is their ability to cripple the very infrastructure we rely on. They can damage satellites, disrupting GPS, communications, and weather forecasting. For a world that runs on technology, a major CME impact is a silent but potent threat lurking in space. While CMEs are like giant solar tsunamis, there's another, more subtle danger that can arrive even faster: solar energetic particles, or SEPs. These are high-energy protons and other charged particles accelerated to near-light speed by solar flares or the shock waves of CMEs. Think of them as invisible bullets zipping through space. For astronauts outside the protection of Earth's magnetic field, SEPs pose a significant radiation hazard. A strong SEP event could deliver a dangerous, even lethal dose of radiation, increasing cancer risks and potentially causing acute radiation sickness. This is a major concern for future missions to the Moon and Mars, where astronauts will be exposed for extended periods. But the danger isn't limited to humans in space. SEPs can penetrate satellite electronics, causing malfunctions, data corruption, or even complete failure. Imagine critical communication or navigation satellites suddenly going offline. These particles can also disrupt radio communications, particularly over polar regions where Earth's magnetic field lines dip down, guiding these particles into the atmosphere. This can affect aircraft on polar routes, forcing them to reroute and leading to delays and increased fuel costs. While we can't see them, solar energetic particles are a constant, invisible threat to our technology and to human exploration of space. We've talked about CMEs hitting Earth's magnetic shield, but what happens next on the ground? When a powerful CME interacts with our magnetosphere, it creates fluctuations in the Earth's magnetic field. These rapid changes can induce powerful, uncontrolled electrical currents in long conductors on the ground. These are geomagnetically induced currents, or GICs. Think of power lines and pipelines as giant antennas picking up these space-generated currents. GICs can flow into power transformers, causing them to overheat, melt, and even explode. This isn't a theoretical risk. The 1989 Quebec blackout, which left 6 million people without power for 9 hours, was caused by a geomagnetic storm and the GICs it generated. A more extreme event could lead to a cascade of failures across the grid, potentially taking months or even years to repair. Large transformers are custom built and not easily replaced. Beyond power grids, GICs can also accelerate corrosion in pipelines, leading to leaks and environmental damage. They can interfere with railway signaling signaling systems, potentially causing safety hazards. While the initial event happens millions of miles away, the consequences of GICs are very much an earthly problem, threatening the critical infrastructure that underpins our modern lives. It's a stark reminder that we are not isolated from the sun's activity, even here on the surface of our planet. The dangers of CMEs, SEPs, and GICs on power grids and satellites are significant, but the ripple effects of severe space weather can extend into surprising corners of our lives. Many systems we take for granted rely on technologies vulnerable to solar storms. Consider GPS and other global navigation satellite systems, GNSS. Geomagnetic storms can distort the ionosphere, the layer of Earth's atmosphere that radio signals from satellites must pass through. This distortion can degrade the accuracy of GPS signals, or even cause them to become unavailable. This doesn't just mean your car's navigation might get confused. It impacts precision agriculture, which relies on GPS for planting and harvesting. It affects shipping, aviation, and surveying. Even financial markets, which use GPS for precise timing of transactions, could be disrupted. High-frequency radio communication used by emergency services, long-haul aviation, and maritime operations can be completely blacked out by solar flares. Imagine search and rescue operations being hampered during a critical event. Furthermore, some research suggests that extreme space weather events might even affect biological systems, with potential links to animal migrations or even human health. Though this is an area of ongoing study, the interconnectedness of our world means that a disruption in one area due to space weather can cascade through others in unexpected ways. It highlights how deeply reliant we are on space-based and ground-based technologies that are ultimately at the mercy of our sun's volatile temperament. So what can we do about these invisible cosmic threats? While we can't stop the sun from erupting, we can get better at predicting space weather and mitigating its effects. Scientists around the world are constantly monitoring the sun using a fleet of space-based and ground-based observatories. Organizations like NOAA's Space Weather Prediction Center and ESA's Space Weather Service provide forecasts and warnings, giving industries and governments time to prepare. For power grids, this means developing more resilient infrastructure, implementing operational procedures to reduce stress on transformers during storms, and having backup plans. For satellites, it involves designing more robust electronics, using shielding, and having the ability to put satellites into a safe mode during severe events. For aviation, it means rerouting flights away from polar regions during solar radiation storms. Research is also ongoing to improve our understanding of the sun and the complex interactions between solar wind and Earth's magnetic field. The more we understand, the better our forecasts will become. International collaboration is key, as space weather is a global phenomenon that requires a coordinated global response. While the dangers are real, so too is the human ingenuity dedicated to protecting our planet and our technology from the sun's more extreme moods. Investing in space weather research and preparedness is not just a scientific endeavor, it's an investment in the resilience of our modern society. Space weather is an inherent part of living with a star. Our sun gives us life, but it also has the power to disrupt it in ways many of us never consider. From the silent threat of CMEs and SEPs to the ground-level havoc of GICs, the dangers are complex and far-reaching. As our reliance on technology deepens, and as we venture further into space, understanding and preparing for these cosmic events becomes not just important, but essential for our safety, economy, and progress. By being aware of these lesser-known dangers, we can support the efforts to monitor, predict, and mitigate their impacts. The future may hold even more sophisticated ways to shield our technologies and protect our explorers, but it starts with acknowledging that the weather report extends far beyond our atmosphere. So the next time you look up at the sun, remember its immense power, both life-giving and potentially disruptive. And remember that there are scientists and engineers working tirelessly to help us navigate the most dangerous space weather you never knew about.